Hello, this is John Harper with Lab 4, Riker Tube, and Resonance. In this experiment, we used a Riker tube to measure the acoustic oscillations and changing pressures. The point of this lab was to test the effect that a pulse combustor has on its environment, and we will be using piezoelectric pressure transducers to measure the changing pressures and a photomultiplier to measure the reaction rate. In this lab, we used 3 piezoelectric pressure transducers to measure pressure constantly. The way this works is that the gas flexes on a diaphragm, and we take the voltage output from that and convert it into pressure. We also use a photomultiplier to measure the reaction rate. The way this works is it measures the intensity of the light of a flame, and we can convert that into reaction rate. The Riker tube contains the gas that travels as it is heated. In order to conduct this experiment, we first need to take our initial measurements of the tube length and starting temperatures. Then we need to connect our instruments and check they are all working. Next, we need to move the burner to its desired location and then take measurements. First off, we measured at 0 while the valve was open, and then we measured while the valve was closed. Then we moved to 2 inches and measured while the valve was closed. And then we moved it up until the resonance couldn't be heard anymore, and that was at 5 inches. And then we moved it down until the resonance could be heard again, and that happened at 0.08 inches. Results: for 0 closed, the frequency was 97. The amplitude was around the 152 to 155 mark. And then the relative phase angle was 103, negative 1.5, 0, and 0.39. The frequency for 0 open was 1 because it couldn't be heard. Could be heard here and could not be heard here. And the pressure was much less because the valve was open, it was releasing gas. And the phase angle was higher on the first for the photomultiplier, and then it was very similar for these, except for the third pressure, which was had a much higher phase angle. For 2 closed, we had frequencies of 397 because the resonance could still be heard here. And then at 5 closed, the frequency was 1 because the resonance was unable to be heard. And then when we moved it to 0.08, the frequency is 96 and 3, and that is because the frequency could be heard, as well as the phase angles was 193, negative 1.46, 0, and 1.05. This makes sense. This starts off as a pressure, gains pressure, and loses pressure. Here are our tube resonance frequency that we estimated. For a 0 closed, it is 2.457. For 0 open, it is 2.457 still. 5 closed, 2.644. For 5 closed is, and for 2 closed is 2.53. And for 0.8 closed, it is 2.49. In conclusion, we found that resonance is much easier to hear if the valve is closed. The different positions made it so that resonance can be heard in different positions and gained or lost at others. Thank you.